Okay, so what we're going to work on now is doing something called molecular masses. This is the key thing we're going to be working with because when we start doing calculations, you're actually going to be involving the masses of compounds. You're going to start with the mass of one thing, and you're going to be able to use it to determine the mass of something else. Okay, so it's just like if you're going to be baking stuff, you know how much of something you're starting with, so you know how much of something you're making. Chemistry is basically just like cooking. The difference is the ingredients we use are relatively toxic. Okay, it's just we make things in the end that generally aren't toxic. Generally, sometimes it's not so good. But with this, what we have to start with is we actually have to go from a name, we're going to go to a formula. That's why we spent some time coming up with formulas. We're going to walk through the first couple together. Okay, so you have to have your periodic tables out. We're going to go through and do this. So before we actually go to the molecular mass, I want to go through coming up with the formulas. Okay, di means what? 2. So if it's dinitrogen, that means I have what? 2 nitrogen. How would I show that I have 2 nitrogens? Do I put a 2 in front or 2 behind? I have put it behind, right? Okay. And you guys already knew the answer to that because what's the formula for carbon dioxide? You already know the answer. What's the formula for carbon dioxide? If I actually write it out, what would you write? CO2. You already knew there was carbon dioxide, didn't you? You knew the di went behind the oxygen. So dinitrogen means it's going to be N2. There we go. Tri is what? 3. 3 what? 3 oxygen. So we're going to go O3. So we're okay on that one? Now, notice I didn't use charges, did I? Why? What?
They're not in the metals.
Yeah. They're both nonmetals, right? And nonmetals either want to share or gain. Well, they can't gain from each other because that would give them both negative charges. So all they can do is share. That and the fact that notice I gave them both prefixes, right? Prefixes are only used with nonmetals. Okay? And that tells you exactly how many of each one you have. But now we notice we've got a Roman numeral. So let's go and pull that in. What's the formula or the symbol for cobalt? CO. What does this tell me? Yeah, it tells me the charge of the cobalt, that it's a +3, right? Phosphide is what? Phosphide. Well, IDE means it's a single element, right? It's a binary compound. So what element is probably going to be phosphorus? What's the charge of phosphorus? Well, look on your periodic table. I gave you a hint. Find this and go to the very top. -3. Ultimately, I'm going to take those things away from you because you won't need them. +3, -3, is that up to 0? Okay, we're good to go. What I want you to do right now is I want you to do 3 and 4. And while you're doing that, I'm going to hand something out real quick. So do 3 and 4, please. Okay, is that what you got for number 3? Relate to us? Okay. So on number 4, if we look, silicon is a metalloid, right? That means it can act as a metal or a metalloid. I said I would give you an indicator as to which way it's going to go. In this case, what was my indicator as to which way it was going to act? Okay, it's going to go first, but also remember this. We said when we start writing these formulas and naming them, we're going to name the thing furthest left or furthest down is going to be listed first. So that's not necessarily going to cover it because we're going to have this here and this here. So we would put that there first. There's something else, but that's a good guess. Okay, there's something else that's going to determine which way it's going to be as to whether it's going to go metal or non-metal. This is what it does. We'd already mentioned it. Oh, come on, you guys know this. You at home, do you know? Well, say something. Don't just sit there. Okay, fine. Darby, help them out. They're struggling out there.
I thought what Jake said, it was first.
Okay. But keep in mind this with that. If I go carbon dioxide, I'm still writing carbon first, right? Even though it's a non-metal. So that means silicon, if it actually is a non-metal, I can still write it first. So that's the one issue with that. Okay. You guys? Whenever I use a prefix, the elements have to be acting as what? Non-metals. Prefixes are never used with anything acting as a metal. Does that make sense? Do you remember me saying that before? Really kind of get that ingrained. Okay. So with that, silicon, fluoride, penta is what number? 5. Now, is it silicon penta or is it pentafluoride? It's pentafluoride. So the 5 is connected to the fluorine. Okay, so it's SiF5. Are we getting okay on this? Okay, real quick, I want you to do actually. Yeah, real quick, let's go ahead and do a molecular mass thing. I'm going to show you how to use this document. This document is on the classroom page. Okay, it's under this week's thing. It's also down in resources. This is only a tool. I created this. Use it, don't use it. It's your choice. Some people really find this useful. Some people really don't like it. It's your choice. Okay? So it's just there to help. Okay? So it's not a requirement. I don't need to see this. I may ask to see your work. So however you work it out, I'll want to see that. So it's just however you make it happen. Please don't tell me, hey, I did it all in the calculator. Because there's certain things I will need to be able to check out. Especially in the day and age to where you could just type everything into a computer and it does it for you, right? Yeah, there's specific rules that we follow that I need to make sure you're following. If you just put it in the calculator, it will mess you up. Trust me. Okay. Answers can be very close, but they would still be incorrect. Okay, so how this device works, I'm going to have you guys work this through with me. Okay, so go ahead and write these down with me, and I will get you calculator. How many of you guys have calculators with you? Okay, if you have calculators, bring them out. If not, I have some we'll bring out in just a second. What I would actually ask you to do is for these first four, on these boxes where you see it says formulas, go ahead and write those down real quick. And those people at home, if you print this off, great. If not, there's a bunch of these in the hallway by the main office. No, they're not sterilized, but they haven't been used this year, so I don't think they were used last year when we had the outbreak. So if you want to sterilize it, grab one of the Clorox wipes. So, it'd be your choice. I would ask if you lick it, you sterilize it before you leave. Okay. Okay, so this is how this device works. This is how I designed it to work. Okay, so basically it breaks it through step by step. Okay, it's just a way to guide you to make sure you're not going to forget something. Believe it or not, students will still forget things because they try to shortcut. But they're going to try to shortcut regardless, so I'm trying to take out some of that issues. So I got my formula, and I'm going to break it out by symbol. You're going to have to do that regardless. Every capital is a new symbol. Atoms. How many atoms of nitrogen do I have? 2. How many atoms of oxygen? 3. So now we need to look at the mass of the atoms. Notice it says only 3 sigdigs. What's the mass of nitrogen? And you only get 3 sigdigs. So look on that periodic table. You only get 3 sigdigs for the masses. And actually, let's have you guys do that right now. On your periodic table, let's have you someplace you can see it. Let's have you write that someplace it will catch your eye, because that will be a standing rule. Our masses will only be in 3 significant digits. It equalizes it for everything. And what that means is we should all be getting the exact same answer on every problem. You ever notice in math class sometimes you're going to get answers that are really close to other people's, but they're not quite the same? This is the great equalizer. This means that we all should be getting the exact same answer because we're handling answers the exact same way. And that starts with us pulling masses off this periodic table of 3 digits. I'm not going to make you write down every single thing here. If you go to AP Chemistry on the test, sometimes they do. And some of their values go at like 6, 7, 8 places. To me, that's ridiculous. Okay, so I usually tell my AP students, like, yeah, let's just not do that. Okay, so with that, what's the mass of nitrogen with 3 sigdigs? That would be 2. One, 2. There's 2 sigdigs. I need to have a 3rd sigdig. Well, I believe that's what it says on the periodic table, right? I need 3 significant digits, and my colored pencils are over there. So 1, 2. So I've got to keep marking, right? I always start at the left, go over. So I'm going to bring you over to this 0. My number has to cut there because that's my 3rd digit. I look 1 spot beyond it. Can it round? So that means the mass of my nitrogen is 14.0. Remember, zeros, ending zeros to the right are automatically significant. So I needed that 0.0. Otherwise, I only got 2 digits. And that's going to take a little bit of practice to remember. But I told you we'd be coming back to the sigdics. What do we got for oxygen? What's going to be the mass of oxygen with 3 sigdics? Let's grab the. Pardon?
12.0.
12.0 that you grabbed carbon. I want oxygen. That's okay. That's a common thing. I'm going to get you guys a better one. I'm trying to figure out where I have the other one. Okay. How many people say 15.9? Okay, a couple of you. Now, here's the thing, and that's actually one reason I brought it up. If you look at oxygen, you're right. And actually, I can go one beyond what's there because I know what it is. It's actually 15.9997. Remember, we get 3 sigdics, right? 1, 2, 3. My number cuts at that spot. But you always have to look one spot to the right. 5 or greater rounds, right? So this 9 is going to round that 9 to a 10, right? And then that 1 kicks that 5 up to a 6. So it's actually going to become 16.0. Does that make sense? And actually, you did exactly what I was hoping someone was going to do. I want that to happen so I can make sure everybody realizes we need to be following our rounding rules. Okay, because I'd rather get it out of the way now so we keep that in mind. Okay, so 16.0. Now, going through, we're just going to do this stuff straight across right now. So that's just a straight multiplication problem. 2 times 14, if you need a calculator for that, great. If you don't, hopefully you can do this in your brain pretty well. 28.0. That's just what the calculator spits out. But the calculators are dumb machines. They do only what you tell them to do. If you've typed in a number wrong on a calculator, and have you ever done that? Hit a number wrong? Is it going to stop you? Is it going to say, hang on, you just put a 2 and it should have been a 3? It's not going to know. And you're not going to catch it unless you're really paying attention. So you really have to be paying attention as you do these. Okay, next you're going to go calculator. I want you to have a mass, and I've reworded this on future ones. It says convert to 3 sigdigs. It's already 3, right? Sometimes you're going to have more than 3, but we're going to have to cut it to 3. Because remember, in sigdig rules for multiplication, you always use the least number of sigdigs in the problems, right? I either have an atom or I don't. So that's an infinite number of sigdigs. That's 3 sigdigs. 3 is less than infinity usually. 3 times 16. I've just done this one enough. Cut it to 3 sigdigs. It's already there. At this point, these are all cut to 3 sigdigs. Now, I want the mass of that compound. So what do I need to do? These are the masses of the 2 elements. If I want the mass of the compound, what do I have to do with these values? I have to add them together, right? So I now have to go through and add these pieces together. This is why I don't trust myself. My calculator simply spits out 76. If yours did the same thing, it would. Remember I said calculators are lazy machines? They're dumb, lazy machines. What do you think's actually over here on the other side of this decimal that it just didn't feel like putting in? A 0. Now, should I probably have a 0? Yeah, because I had zeros here, right? These are saying I've truly measured out to 28.0. So if that one's actually 48.0, this should actually be 76.0. So you've got to watch that because it does show us how much we can trust those numbers. Now remember, with addition subtraction, our numbers were based on the least precise value. And this is where I was using those colored pencils, figuring out where the one marked for the last one, and then the answer furthest left. Well, in this case, they were the same. So we get that. Does that seem pretty straightforward? Okay. So what I'm going to have you do right now is I want you to try this on the same thing here. I'm going to go ahead and pause the video, and I want you to go through and do cobalt phosphide. And hopefully I'll be able to pause this somehow. And those people at home, you're just going to continue to watch me until I figure out how to pause this thing. Okay, and people at home, I can't figure out how to make it pause, so you just got to sit there and watch. Just fast forward through this. I'll figure it out eventually. Yes. Yes. Here, I need to give you a pass. And then sign out and then sign back in, please. There you go. No. I'm sure they probably would like you to, but I don't think it's a big deal.
Right. Over here.
Okay, I'm recording twice. Okay, we got it? Got some yes, some no? Okay. Mr. Winter, you got it? Yep. Jake? Anthony? Yep. Gabriella? Okay, and if I can actually get, there we go. 89.9? Does that seem pretty straightforward? Okay, so real quick, Li2S, do you think that's going to be really any different? No? Okay, So what I would like you to do, let me double check one thing to make sure it's going to do what I need. Whoa. No. Okay, what I want you to do right now, we know Li2S is going to be the same. I'm going to ask you to do that one, but what I want you to do right now is I want you to move on to SIF5. Please do SIF5 right now. Okay? Because I want to see something, or I want to show you something. You should actually catch two pieces. What do you guys see as the mass for fluorine?
What? What's the fourth one? 08. So, let's do the same. Yes. The third one, 28 is 0.9.
Okay, mass of your fluorine is incorrect. I just realized that.
0.9.
I don't know why it's that. That is weird. That's really weird. Okay. Like I said, I will get you new periodic tables out because that's a little bizarre. This one's, yeah, this one will work. I'll adjust this one. Fluorine is, you can't even see it, so let me unfreeze it. Okay. Fluorine is 18.998, and then there's more beyond that. Fluorine is 18.998. So I'm going to have to send out new periodic tables. So for those people that are in class, I'll have more for you guys here. For those people that are remote at home, you're just going to have to print off new ones. I'll have some in the main office if you want to come in for some. But I don't know why it's like that. That is just kind of weird. So, but like I said, I've got to adjust this one because there's no room for the polyatomics. But it's 18.998. So you can see better. Oops. Okay, so we're ready to come back on that one? Nope. Okay.
I mean, I think maybe most of them are ready.
Hmm?
I think most of them are actually ready.
Okay.
Not those two.
No, it just takes time. It's gonna take. You know this. It takes practice. It's gonna do that for everybody. It was 58 when I walked in this morning.
58 degrees.
In here,
Yikes.
it was cold.
That's how close. So that you're talking about like the weather here and stuff. That Friday night before break, I worked at the hospital that night. The wind here.
I heard.
Well, something happened at the hospital. When I left work that morning, it was 57 degrees in the lobby at the emergency room. It was terrible. It was creepy. When I drove home Saturday morning, it was pretty creepy. And even clouds, like most of the power was out. The wind, the snow drifts everywhere. It was pretty bad.
Wow. I thought you guys didn't have snow on Friday.
Friday night, it
Oh,
snowed
okay,
and the
okay,
wind was
okay.
blowing. Because I worked overnight.
Okay.
It was pretty bad.
Okay. So looking at this, going through, and we got that silicon. Turn it this way. Was 28.1. So 28.08. We got to go to 3 sig digs, 28.1. There's one of them. Keep 3 calculators this, 3 sig digs, great. Lita, we figured out the fluorine on that is incorrect. It should be 18.998. It says 18.0. I don't know why. So with that, fluorine, there's 5 of them from the pentafluoride. 19 is its mass. So 5 times 19 is 95. Adjusted 3 sig digs were great. So stops at the tenths, stops at the tenths. Did it now, could have done it later. So when I put them into the calculator, I'm adding them because I want the total mass. I'm going to get a mass of 123.1. Now that's my total mass, right? I need to figure out where my answer cuts. And remember, addition, subtraction is always based on the least precise number going in. Well, this one stopped at the tenths. This one stopped at the tenths. So guess what? My answer has to stop at the tenths. So that would mean that this is actually also my answer, even though there's more than 3 significant digits. That doesn't matter because it's based on how accurate my number is. Multiplication division is only based on significant digits. Addition subtraction is based on how accurate those values are. So that's where the big difference is. These can only be 3 digits, only 3 sig digs. This can be more. Keep that piece in mind. This can be more than 3 significant digits. It may not always be. It might just be 3 sig digs, but it can be more. Okay. Keep that in mind. So with that, what I'd like you to do is go ahead and work on 7, finishing up through 7. I'm going to put them up here real quick. And then what your homework is tomorrow is, we'll put that up, is go ahead and finish the worksheet for 8 through 15. Is this pretty straightforward stuff? Do you see where that worksheet, that tool kind of helps? Kind of focus. If you don't like it, find a different way. That's fine. I'll have a Google form set up where you just enter your answers. Okay. Go through. Now, if your formula is not right, are you going to get the correct mass? You can't, can you? That's why we stressed getting the correct formulas. Because if for some reason you would have written this as just LIS, yeah, you would get a mass, but it's not the correct formula, so your mass would be wrong. And on a Google form, one of the answer choices I'm gonna give you is an answer for the most common student mistakes. I'm not just gonna say, okay, 39.5 for one answer, blue monkey for the next answer, slice of pizza for the next answer. I need to make sure you know what you're doing. Is it a big deal? No, but it's a learning tool. Okay, so keep those in mind. Because I do need to show you, okay, hey, I've got to really watch this. Okay, but you can do that. Okay, so I'm going to stop recording. And with that, people at home, I'll post 5 through 7 somewhere. Look online. So with that, we're out.